In problems 13 through 21, we're going to graph two linear equations and see where they cross. Here is a system of linear equations. We want to get them in y equals mx plus b first. The second equation already is in y equals mx plus b form. The top one isn't, so let's fiddle around with it till we can get our y alone. The first thing we can do is get rid of our x term by throwing it to the other side. That will give us 3y equals 12 minus x, because when we switch sides, we switch signs. Next, let's switch these two terms around. The 12 was positive and it needs to stay positive. The x was negative and it needs to stay negative, but we can put them in a different order. Last, we need to get rid of the 3 touching the y. This is a times 3, so we need to divide by 3. After dividing everything by 3, we get y equals negative 1/3 x plus 4. Here, the times 3 and the divided by 3 canceled out, we got y. Here we had a slope of negative 1, and negative 1 divided by 3 is negative 1/3. And here we had 12 divided by 3 equals 4. Now that we got our first equation transformed into y equals mx plus b form, we can carefully graph both equations. Let's start with this equation. The slope equals negative 1/3, and the y-intercept equals 4. First we plot the y-intercept, then we use our slope to find the second dot. We had a run of 3 and a rise of negative 1. We can keep using this slope to find more and more dots. We can even go the other direction. On the other equation, our slope equals 1 and our y-intercept equals negative 4. First we plot the y-intercept, and we use our slope to find a second dot. Our slope is 1, which is 1 over 1, so we run 1 and rise 1. We can use the slope to find more dots. Now we can see where they cross. The two equations cross at this point, which is 6, 2. You can actually draw on your lines if you want, but you don't have to. And that's the process. Make sure both equations are in y equals mx plus b form, plot your intercepts, and use your slopes to find all the dots and find where they cross.